In this lecture, we're going to learn about inline variables and functions. And this is a facility we have in the C++ programming language to be able to violate the one definition rule. If you remember, we have said that it isn't possible to have two definitions for the same name in a same file or even across different files or translation unit. If you do this, you're going to get redefinition errors, be it a compiler error or a wrinkle error. But sometimes you really want to do this. Suppose we have a setup like this. We have a variable age and we have a function, some function, and we want these guys to show up in different translation units, just like this. And we want, for example, the values we have in the age variable here to be the same. I know some of you are asking, why on earth would I want to do something like this? But let's first look at how we can achieve this. Then I'm going to show you why you would need to do something like this. To be able to do this without a problem, you can mark these names as inline. For example, we can mark the age here as inline, and we can mark some function here as inline, and do the same thing for utility2 here. And these names are now going to be confined to the translation units within they show up. So age in utility1 is only going to be usable in utility1, and age in utility2 is going to be only usable in utility2, and that's going to avoid the one definition rule, and we will still be able to use these names without a problem. So we achieve this by marking these guys as inline. We can achieve this by marking these guys as inline. In utility1, we have age as inline, we have our function here as inline, and we do the same things in utility2, and this is going to allow us to use these guys across translation units without a problem. Okay, so once we mark these guys as inline, the compiler is going to do something really cool behind the scenes. The compiler is going to unify these guys into one. For example, this age is going to be a single variable in the eyes of the compiler, and this function here is going to be the same function, but we will be able to manipulate it across different translation units. And this is something you need to keep in mind. For example, if we were able to set up a function like this to print the age here through the print age function here, we would be able to see that the age variable we have here is the same across translation units, but we can't use the age across translation units. Each age is going to be confined to its own translation unit. I know this may be confusing, but bear with me. We're going to head over to Visual Studio Code in a minute, and you're going to see that this is really cool. Okay, so now that we know how we can mark our functions or variables as inline, let's address the question of why we would want to do something like this. Suppose you have a utility file, a utility header file here, and inside we have a variable and a function, and we want this to live in a header file so that we can include this in multiple files. So remember, including a header is just going to copy the contents of the header. And if we did this without inlining this variable and function, we would be violating ODR, or the one definition rule, because these functions and variable, the definitions for them would be showing up in multiple translation units, and that would be bad. We would get compiler errors. So marking these guys as inline allows us to set up header files like this. And this is really important for people building header-only libraries where everything is going to be living in a header file. We can mark everything as inline, and then we will be able to include that header in whatever CPP file that we want. And that's going to be really cool. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is inline variables and functions. We're going to grab our template files pretty quick. We're going to put them in place. And we are going to open this in Visual Studio Code. Let's do that by dragging and dropping here. This is going to give us our main CPP file so we can clean up a little bit. And we're going to set up the same scenario we had in the slides. So we're going to set up two files. We're going to have utility1.cpp. And we're going to have utility2.cpp. Inside utility1, we're going to have the code we had exactly in the slides. We have an age variable, we have some function which is going to print our age and print its address. but we want to have exactly the same thing in utility 2. So if we try and compile this program, this is not going to go well, because now we have the definition of this variable and this function twice in this program. So let's try and even compile this without using it in main and see if we get a problem. So let's build with GCC, and we're going to see that we have a problem, and the problem is going to be that we have multiple definitions for our function, which is some function. We also have multiple definitions for our age variable. If we hunt this down through this output, we're going to see that we have multiple definitions for age, and this is bad. So if you want to be able to do something like this, you would mark these guys as inline, and it is really easy. You go in front of each variable or function, you say inline, and we're going to do the same thing. We do this in utility 1. We're going to also do the same thing in utility 2. Let's do the same for our function here. And now if we compile our program, we're going to see that it is going to work. Let's do this. We're going to build with GCC. Now the compiler knows that even if these guys are showing up twice in our program, each one is going to be confined to its own translation unit. So age here is confined to utility 1, some function here is confined to utility 1, and the same thing is true for utility 2. This age is confined to utility 2, and this function here is confined to utility 2 here, and they are not going to conflict with each other. So one thing you should know is that for this to work, this variable and these functions have to have exactly the same signature. For example, for the function here, we can't be returning double, and in utility 1 be returning void. They have to be the same for this kind of inlining to work. And this requirement is in place because the compiler is going to unify these guys. So this age we have in utility 1 is going to be exactly the same as the age we have in utility 2. And if we try to print their addresses, we're going to see that they are exactly the same addresses. So let's go in our utility 1 and put in a function that is going to call some function here, because we can't really call this function from the outside. And let's show you this. Let's go in main and try and call it. We're going to go there and say void some function. We're going to declare it. And if we go in main and call it, we're going to say some function. We're going to see that the compiler is going to say this function is undefined. I don't know what this thing is, because functions in utility 1 and utility 2 are inaccessible for any other translation unit. So we are trying to use these guys from the main translation unit, and these functions are confined to the translation units utility 1 and utility 2, so we can't use them from main here, and we're going to get a compiler error. Let's do that. We're going to build with GCC, and we're going to see build finished with errors, and we're going to see undefined reference to some function here because this function is inaccessible from the main translation unit. So you should really know this. But we can still go in there and set up other functions. We're going to say print age utility 1. Let's do that. And this is going to call some function. We can do this because this function is going to be accessible from the outside, but because it is in this translation unit, it can call things that are internal to this translation unit. So to make this super clear, we are going to head over in this print age utility function, say that we are printing from utility 1. We're going to do that. This is going to make things super clear. And we're going to go down and say stdc out to give ourselves some space. We're going to go in the utility 2 file and do the same thing. So we're going to put up a function which is going to call some function, but this is going to be print age from utility 2. So we're going to say that here, and we're going to say that right here. And we're going to see that the compiler is going to unify these some function calls. Again, the implementations for these things have to be the same. Something you inline, it has to be exactly the same from utility 1 and utility 2. And we can see that they are the same. What we have in utility 1 is exactly the same thing we have in utility 2. So this is a strong requirement. Because the compiler is going to unify these two guys, so they have to be exactly the same. Now that we have this, we can head over to the main function and delete whatever we had in there. we're going to grab our definition for print age utility function here. Let's grab it. We're going to use it in a minute. We're going to delete the declaration here because it is useless at this point. And we're going to put a declaration here for utility 1. We're going to grab this and copy and paste it to have utility 2. And we can call these functions now. We can say print age from utility 1 and print age from utility 2. That's what we want here. And if we build and run this program, we're going to see that the build is going to be good. Let's do this. You see, build finished successfully. We can clear and run Rooster. Now we see that if we print from utility 1, we're going to see age 12. And the age variable is going to be leaving at this address ending in 0E0. We're going to see that what we have in utility 2 is exactly the same. So the compiler has really unified these definitions that we have in utility 1 and utility 2. And variables and functions we have in this translation unit, for example, age and some function here, are the same thing from the perspective of how things are represented in memory. So this is the benefit of inlining your variables and functions. They are going to be unified, and in memory you're going to be basically manipulating the same thing. But from the perspective of your code, each definition is going to be confined to its own translation unit, and this can come in handy in many situations. Now that we know this, we're going to see why we would need something like this. What we're going to do is set up another utility file. I think I should close this thing, open editors, because this is confusing me. I am going to add another file. I am going to call it utility.h. And inside, I am going to put in a piece of code I have prepared before. So this is going to have an inline variable called threshold, and the function is going to add up at condition. So if a and b are greater than our threshold, we're going to return the sum, else we're going to return our threshold here. Suppose this is something meaningful for your application, and you want this code to live in a header file so that you can include it in other translation units. So what we would have here is a problem. For example, if these guys are not in line, we're going to remove this keyword here. And for example, we went in the main function and included utility 1 or utility. We can do that. And we're going to go, for example, in our utility 1 translation unit and also include utility. And to try to compile our code, we can do this. We're going to try and build this with GCC like we always do. We're going to have a problem. So you see, we have a problem here, and it is saying multiple definitions for the add function. And where is this coming from? Well, we have a function here and we have a variable. We have the add function. We have this variable. This is a definition. You have to remember this. And what we have down here is also a definition. But we are including this file in multiple translation units. So what we have in our utility header is going to show up in whichever translation unit where we include that. So in our main CPP file, we're going to have our variable and a function. And in utility1.cpp, we're going to have the exact same thing. So these things are going to be included in multiple translation units, and this is going to violate the one definition rule. And we can solve this problem by marking them as inline, and this is really cool. So we can make this thing usable and still have the flexibility of implementing our things in a header file. This is really important for header file only libraries, and this is really cool. So now that these guys are in line, we can build our program, and you're going to see that it is going to work. And this is really cool. For example, you can head over in the main function and use the add function here if you wanted. If you wanted to use that in utility 1, you could use it, and this won't be a problem. This is how inlining your variables and function can really come in handy. This is really all I wanted you to see in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to try and compare the inlining we just learned about in this lecture to things that have internal linkage, Think about a function that you have prefixed with the static keyword, or a function that has been wrapped inside an anonymous namespace like we have seen before. And we are going to compare these things and see how they are different. So go ahead and finish up here and meet me in the next lecture.